In this video, we'll learn how to find the inverse of a 3 cross 3 square matrix. And now we know that since I is an identity matrix, so multiplying I with any matrix will give us back the same matrix. So A into I will be A. Now for column transformation, we'll write A as A equal to A into I. First matrix A will come, then matrix I will come. Now why we have to write matrix I for, later on? Because we have to work out on this matrix I, that is the unit matrix. So for that one, we know that already we have gone through matrix multiplication. How do we multiply two matrices? Suppose this matrix 1 is the second matrix. While doing matrix multiplication, we are taking the rows of the first matrix and multiplying with the column of the second matrix. So R1 will multiply with column 1, similarly R2 will multiply with column 2, R3 will multiply with column 3. And this is how we are doing the matrix multiplication. So because we are doing here column transformation, we will be working only on the columns. Therefore, we'll because A into I combined will give us A, and as I told you that matrix multiplication is only done when we multiply the rows of the first matrix with the columns of the second matrix. So since this is column transformation, we'll work out only in the matrix I, and in rows and columns are coming later on, so we'll take I in the later half. Do not write A as I into A. So you may get the answer, but theoretically it will not be correct. So whenever you are doing column transformation, A is to be written as A into I. But suppose if we have to do a row transformation, we'll write A as A equal to I into A. Now let us see how we can do. The best way is how we'll do is that we have to transform this matrix. On the left side, you write down the elements of matrix A. The right side, A into I is there. Matrix A write as it is without writing the elements, and in the second one, that is I, write all the elements of I. Then we'll transform this matrix to the left side into an identity matrix. If suppose this is an identity matrix, then A into whatever it is will get I. That means the second half of this will be the inverse of the matrix A. So this is how we'll work it out. So here you recall, you know what is identity matrix. First row is 1 0 0. So in column matrix, you have to first convert the first row as 1 0 0. So here it is 2, here 0, here -1. So first of all, we'll make this as 1, because identity matrix first element is first row, first element is 1. How we can do? Only we'll now take columns. So as already you know that we can add 2 columns. So here we'll in column 1 C1, applying C1 plus C3. Why we are doing C1 plus C3? Because 2 minus 1 will become 1. First entry of identity matrix is always 1. So we'll apply this one. Let us see what we get. We cannot do only for one single element. The whole column is to be added. Column 3 is to be added with column 1, and remaining columns will remain same, and this we will have to do on both sides, right side as well as left side. Whatever operation we are doing on the right hand side, that same operation has to be done on the left hand side. So adding these two, columns. Column 3 will be added in column 1. So 2 minus 1 will get 1. 5 plus 0, that will be 5. 0 plus 3 will be 3, and remaining columns will remain as it is. 0 1 1 and -1 is 0, and this is 3, equal to A will remain as it is. Now here also same way we'll add the column 3 in column 1. Column 3 is to be added. Column 3 is to be added in column 1. So 1 plus 0, that is 1. 0 plus 0 is 0, and 0 plus 1 is 1, and remaining 2 columns will remain as they are. That is 0 1 0 and 0 0 and 1. Next one, we are already if you see the identity matrix, first row the elements are 1 0 and 0. So 1 is there, 0 is there. Now here we are having -1. how can we make this as 0? If we add the column 1 with column 3, this entry will become 0. We have not to worry about the other entries. Just we'll convert the first row in the form of identity matrix row, that is row 1, 1, 0 and 0. So 1 we have got, 0 we have got. Now we have to convert this minus 1. We have to transform this into 0. And how we can do? Just add these two. So we'll add column 1 with column 3. So applying we'll get C3 becomes C1 plus C1 plus C3. So in column 3 you add C1, so C1 plus C3, this is what we are going to do. Column 1 and column 2 will remain the same. Column 1 and column 2 will remain the same. Now 1 5 3 0 1 1, and when we are adding them, what we are getting, 1 minus 1 and added in this minus 1, that will become 0. 5 plus 0 is 5, 3 plus 3 is 6, equal to a into, remember that same operation, this is whatever we have done here. C3 is to be transformed as C1 plus C3, so that is to be done to the left side also. So we'll get first two columns will remain without any change, 1 0 0 1 1 0. Now in C3 we are adding C1, so 1 plus 0, that is 1, 0 plus 0 is 0, 1 plus 1 is 2. So this is our second operation. Now next, in identity matrix, you know that second row first and middle entry is 1, and remaining two entries, that is the first element of row 2 and third element of row 2, both are 0. So we have to make this as 0 and this also as 0. So how we can do? It's very simple. Applying now if we multiply column 2 with 5 and subtract with column 1, we'll get 0. So let us do this one. Column 1 becomes C1 minus 5 C2. See here, if you multiply column 2 with 5, so this will also become 5, and subtract with column 1, what we are going to get is 0. So let us do that operation. We'll get here 1 0 0. Now 1 minus, see here, now next one is whole. So multiplying with 5 minus 5 will become 0, and this we have to multiply with 5. So 3 minus 5, that will become minus 2. Remaining columns will remain as it is, 0, this is 1, this is 1, 0 5 6, equal to a. So it will be better if you first write down the remaining two columns, that is 0 1 0 1 0 and 2. Now see, what we have to do is, in column 1 we have to multiply column 2 with 5 and then subtract. So 5 into 0 is 5, so it will not make, there will no change, this will remain as 1 only. Then multiplying this with 5, so it will become 5, and then subtracting in the column 1. So 0 minus 5, it will become minus 5. Then again C1 minus 5 C2, 1 minus 5 times of 0, that will become 1 only. So this is what we are getting here. Now here you can see that this element is 5. To make it 0, what we can do is, we will multiply column 2 with 5 and subtract from column 3. So let us do this step. Applying C3 becomes C3 minus 5 times of C2. Let us see what we get. So best thing is that we'll write the first two column 1 and column 2 as it is, because there is no change in column 1 and column 2. So 1 0 minus 2, 0 1 and 1. Now column 3, multiplying the column 2 with 5 and then subtracting from column 3. So 0 multiplied with 5 is 0, and there will be no change in third column, so 0 as it is. Then 1 into 5 minus 5 0. Then multiply 1 with 5 and subtract from 6. So 1 into 5 is 5, 6 minus 5 is 1, equal to a. Similarly we will do here. First two columns there will be no change, 1 minus 5 1, then 0 1 and 0, then again same way we'll multiply, because here C3 minus 5C2, this column from column 3 we have to subtract 5 times the elements of column 2. So 5 into 0 is 0, so there will no change here, it will remain 1 only. Then 5 into 1, 5, 0 minus 5, it will become minus 5. And here also 5 into 0 is 0, so it will remain 2 only. Next, what we can do is, you can see it here, row 1 is same as that of INT matrix, row 2 is also same as that of the INT matrix. Now in row 3 we know that the first element of row 3 of INT matrix is 0, so we have to make this as 0 and this one also 0. First we'll make this one as 0. For that, what we can do is, we can just multiply column 2 with 2 and add with column 1. So column 1 applying, what we can do is here, applying column 1 becomes column 1 plus column 2 times of column 3. So this will give us, so there is no change in column 2 and column 3, so only column 1 is being changed. So multiply column 3 with 2 and add with column 1. 2 into 0 is 0, so there is no change here, it will become 1. Again 0 multiplied with 2, so there is no change, it is 0 only. 0 plus 0 is 0. And for third element, multiplying column 3 with 2 and then adding with the elements of column 1. So 2 into 1 is 2, 2 plus minus 2, there is 0, 2 minus 2 is 0. Then remaining 2 columns will remain as it is, 0, 1, 1 and 0, 0, 1 equal to A. So here also we'll multiply column, whatever operation we have done to the left side, that same we'll do to the right side. So multiplying column 3 with 2 and then adding with column 1. 2 into 1 is 2, 2 plus 1, that is 3. Then minus 5 to 2, 10, minus 10, and minus 10 will add with minus 5, that is minus 15. And 2 into 2, 4, 4 plus 1 will give us 5. Remaining 2 columns will remain as it is, 0, 1 and 0. 1 minus 5 and 2. Now in the third step, the last step, what we are going to do is, we'll because we know that in INT matrix, in the third row we are having the elements 0, 0 and 1, so we have to make this one as 0. It's a very simple one. From column 2 we will subtract column 3 and it will become here 0. So let us do that one. Okay, now we'll do the remaining part. So here, as I told you, we have to make this as 0, because third entry, because in the third row of INT matrix we are having the elements as 0, 0 and 1. For that, what we can do is applying C2 becomes C2 minus C3. So this is what we'll do. So 1 0 1 0 0 and this is the third one, 0 0 1 equal to A. Now let us see here, C2 minus C3, so we have to subtract these two. 0 minus 0 is 0, 1 minus 0 is again 1, and 1 minus 1, that is 0, equal to A. Now here 3 minus 15, 5, and there is see here, applying C2 becomes C2 minus C3, that means there is no change in column 3, so column 3 will write as it is, 1 minus 5 and 2. Now we have to operate only on column 2, so 0 minus 1, that will become minus 1, 1 minus minus 5, that will become plus 6, and 0 minus 2 will become minus 2. So this is what we are getting, and you can see here what we have got it here. We have got here identity matrix. Therefore, because we know that already we have discussed that whenever the matrix multiplication of two matrices is equal to I, then both are inverse of each other. Therefore, inverse of A will be this matrix. So here we are getting A into B equal to I. Therefore, A inverse equal to, A inverse equal to 3 minus 1 1, minus 15, 6, minus 5, 5 minus 2, 2. So this is our inverse matrix of matrix A. Now for practice work, practice work, do example 1, this one. Do example 1 by row transformation, row transformation, row transformation, row transformation. Now in this one, how to do by row transformation? What we have done is here, we have taken a equal to a into I. What you will take is a equal to I into a. Then instead of seeing in column, what we are doing is we are seeing the rows. When we are seeing the, when you will be taking, when you will be doing by row transform, see the column. First column we know, compare with the, you must remember the identity matrix 1 0 0. So here it is 1, this one you have to make it as 0, and this one also as 0. It's very simple one. What you can do is multiply R1 with 5 and then subtract with R2, multiply R1 with 3 and subtract from R3. So this will become 1 0 and 0, and similarly you can do for column 2 and column 3, and you will get the identity matrix A. So try it. Where is that? This one. Do not forget to do this question. Do example by row transformation.